Alright, so let's go over a bit about converting circuit diagrams. So, for both going from real to simple and then simple to real, there's actually just a very easy method just to do it. It's very mechanical and it takes thinking for sure, but it's not that difficult to think about. So, let's first go about converting a real circuit into a simple circuit. So, to do this, it's really only one step, and what you have to do is basically invert one or two, or however many gates you need. You need to invert it so that this bubble basically will be pushed over to this side and then become two output signals. Now you'll have the output signal in line with an input signal, and same thing over here. Now when this happens, these four inverters will actually cancel out, making this a much easier circuit to read. So let's do this first. Let me copy over this. Alright, so let's change this gate right here. Let's change it into its inverted form, and we know that since it was a NAND gate over here, we can actually switch it to an OR gate, a NOR gate, sorry. And now both of its input signals are on this side. What we did is just push this bubble over to this side. So now we have an equivalent of a NAND gate right here. So now that we have all of our inverters on this side of the gate, these will now just cancel out. And now all we're left with here, let me copy this one again, just so I don't have to draw it out and waste your time a lot just watching me drawing stuff. Now, since these bubbles are actually gone, this will actually be an OR gate. Now we have a much simpler circuit. So this is an AND gate now, since it doesn't have any inverters on it. This is also an AND gate, and this is actually just a simple OR gate. So that's how easy it is, just converting from real to simple. We'll go over more difficult examples inside the tutorial video, but that's just basically the basic concept behind converting from real to simple. Just find a way to push this bubble into the other side, or even vice versa if you have two input signals and then you want to convert it over to this side so that it matches with another input signal. So the output signal of this side will match with the input signal on this side. Then you just find a way to do that, and then all of them, anytime you do that, it'll cancel out and make your circuit much simpler. Alright, so the last thing we're going to look at here is how to convert a simple circuit into a real circuit. So to do this, the first step obviously is to have your circuit. Here I have a bit of a more complex one than I had for the real to simple example, but it shouldn't be that hard to get my point across here. So I wrote down the equation right here of the circuit, and you can tell that it's in simple because of how easy it is to read that logical statement. So now I'm going to convert it into real, because now the circuit works fine, so we're going to build it. So let's do this. So the first step we need to do is determine the layers of the circuit. And what I mean by layers is everywhere there's a connection, you have to it's considered a layer. So right here is your first layer. That one is you can tell because of all the connections being made here. Next would be, if I move this over a bit just to make it a little easier to see, your next layer will be in this section because of all the connections being made in this area. Your next one would be here, and finally your last one would be this little one right here. It's pretty easy. I'm sure when you get into more complex circuits, it might be easier to, or it might be harder to recognize where these layers are, but it will come to you as you practice more. So, next thing you have to do is figure out which layers you're going to use for your inversion. So, either you're going to use, I'm going to label these as 1, 2, 3, 4. Either you're going to use 1 and 3 here, or you're going to use 2 and 4. So for this example, I'm going to decide to use 2 and 4. So I'm not going to cancel that out yet because I'm going to copy this over. But for this one, I'm going to use 2 and 4. So let's copy this over now so we can start figuring out where we're going to invert everything. Let's take a copy of that, and okay. Nice. So we're going to use layers 2 and 4, so I'm just going to take out the circles, the stupid circles I drew. Why did I do that? Okay. So as I'm explaining, or as I'm doing this, so what you have to do here is basically put an inverting circle on both ends of the leads. In this case, you don't want to change, you don't want to convert the gate into its equivalent gate. You want to change it, you want to just add a lead to the beginning and the end. So right here there's an output on the OR gate right here. So what I'm going to do is draw a inverter here, and we can see that it leads to this input gate. So I'm going to add in another inverter right here. So that's the first one I see right there. Next I'm going to add a inverter here, and you can see it leads to here, so I'm going to add this inverter here. Now here is where it gets a little interesting. So I can add an inverter on this input gate and this input gate. But as you can see, it leads to almost nowhere. So what I'm going to do, and this is completely legal, is add in a NOT gate here. So now this NOT gate, you can tell I'm bad at drawing, I'm sorry, is going to be inverted. So now you've taken care of the fact that there is no gate on the other end of this inversion. So now now the NOT gate just acts as your inverter, and it's all good. So now you gotta do, since we're using layers 2 and 4, we have to add our NOT gate in over here, since there's no gate on the other end of this one. So there's another inverter, and here's our NOT gate with an inverter right here. Cool. Okay, let's move on to the next step. And here we can see a little trick. If you noticed, in the original circuit, let's move up here for a second after my thing lets me right here. Okay. In our original circuit, we have an inverter right here. So we can see that this inverter is actually connected to C, right? It's connected to the input C. So we need to keep this inverter valid still. So a way we can do this is, instead of putting our inverter here, we can move this up to the position right here. Let's redraw this a little bit so it's easier to see. Okay. So instead, let's draw this NOT gate right in this section. So now we've taken care of the inversion that will happen right here. So we can get rid of that knot. And we've also taken care of the inversion that's going to happen right here. It simplifies your circuit so much when you can find areas like that. So that's one trick that we learned in class about this whole thing. So let's move on to step 5. Now is when we can start using our substitutes that we learned earlier. So I'm going to copy over this one more time. So now we have our circuit as it was in step 4. So let's look at step 5 now. So now what we're going to do is take our unconventional gates, and the unconventional gates are defined as the gates that have input bubbles on them. So right here, here's one unconventional gate, here's your other unconventional gate in this circuit. So in this case, we have two NAND gates. And we know that our NAND gate has an equivalent gate of a NOR gate that has a output bubble. And this is our equivalent NAND gate. So what I'm going to do is take out these guys. Bye bye, you were nice to us. Alright. So we're going to take that out, and we're going to add in our NOR gates right here. Right, there you go. So now that we have all our inputs pushed over to the output side for layer 2, let's just look back at layer 4. So now, right here we see that the two bubbles are basically on the same side of each other. There's an output connected to an input. So in the case of simple and real, we really don't want that. That's why we changed all our bubbles over in this part. So to take care of this, all we have to do is push our NOT bubble from this end into this end. So there we go. We have completed a conversion of a simple circuit into a real circuit. Now we're ready for construction. So thanks for watching this video, and I hope see you in the tutorial video.